Thank you very much. The first thing I'd like to do is thank all of you. I know that there are a lot of people here today who made a lot of contributions to this mission, and the mission went very well because of all the work that everybody did here at JSC, JPL, and the Kennedy Space Center, and many other places around the United States and around the world. This mission was a real team effort between a lot of groups that don't usually work together on projects, just because we don't usually do that many projects with the Jet Propulsion Lab. But in this particular case, everybody worked together as a team, and the end result, I think, speaks well for that teamwork. And so I'd like to thank everybody out in the audience who participated in one way or another to this mission. The second thing I'd like to do is introduce the crew up here, and then we'll get on with the video and the slides. To my right is the pilot, Kevin Chilton. And then we have the payload commander, Linda Godwin, and the MS-1 and the second shift commander, Jay App, and our MS-2, our basically flight engineer, the fellow that helps us going uphill and downhill, Rich Clifford.
I kept from being afraid.
And then we have Tom Jones, who was the payload commander on the second shift, and will be the payload commander on STS-59. And they're going to be off doing this mission again in a different period of the year. And that's basically the flight crew. And all of them worked very hard as part of this overall team and overall crew. And with that in mind, now I'd like to get on to the interesting, hopefully the interesting part of this afternoon. And we'd like to show you a little bit of our crew movie and then some slides we took of the planet Earth while we were up there. So if we can roll the movie. This was our patch. Kevin Chilton was in charge of making sure it all got approved. Most of the design was actually from Tom Jones. This is us while we're on orbit. You can tell that we're having a good time. This was our crew press conference while we were up there, and just gives you another chance to see all of us up in space. This was the morning we actually launched. We're headed out to the pad. We went out twice and launched on the second attempt, so we were happy to do that. It turned out that the weather wasn't that great after we launched, so if we hadn't gotten off that day, we'd have been waiting around for some time. The vehicle really feels great when those main engines finally start. They run for about 7 seconds or so, and we launched right at the crack of dawn. So as you can see here, I know some of you were down there for the launch. It had to be absolutely beautiful. The only better view was in the rearview mirror. That was the view we had as we were headed up there. And we've got a number of launch pictures here just because I think it was an incredible launch. You can see we're arcing up toward the north, heading into a 57-degree orbit. It was a beautiful, crisp morning, so they were able to track us for a long range, so we've got a lot of good launch video here. And it feels like you're awfully small out on the end of this giant explosion, which is exactly what it looks like here. You'll see the SRBs come off, and then you'll see a shot from the orbiter itself as the SRBs come off. And then you can see it was so clear that morning that they've got some good shots here of the SRBs falling away or floating away. And the main engines continued to burn. Our children told us we looked like a star going over the horizon. And really felt great to get into orbit that day. Here's the external tank separation. We don't see this real time, and that's probably good that you don't see all those things floating around. Might make you just a little bit nervous, but that's all basically ice and things like that floating around. It's not really a problem. And the next shot is one Jay took after we rotated the vehicle to get some footage of the external tank, and Linda was shooting some 35mm shots at this time to get data on the tank.
Now we're on orbit. This is the sunrise, and as the sun comes up, it's just a beautiful view of seeing the tail of the orbiter come into view, and then our payload in the payload bay. You can see the large antenna structure, the JPL project and the German and Italian space agencies, a large antenna. And in the foreground, where you can't see it, is the platform for the sensor from the Langley Research Center. In the forward flight deck, Sid's busy here putting in one of the 412 maneuvers that we did during the mission. Basically, wait for one maneuver to time out and then enter in the next one. Those allowed us to do some yaw steering to help the radar ambiguities. Another major thing we performed during the mission were all the tape changes, and Tom's doing one here. We did, I think, 163 tape changes on time during the mission. That's where all the radar data was recorded, and we had 2 recorders on the left side of the aft flight deck where Tom is working here, and another one on the other side for 3 total. The aft flight deck was where the action was on this mission, there's no doubt about it, and we had some extra panel covers made with Velcro squares on them. You can see them in the back, and basically it held all of our cameras and lenses, and Sid was using the Linhof, and Chili's just surrounded by Hasselblad camera bodies and a spot meter or 2 and ready to go to work. This is our Linhof film changing bag. I did it a couple of times during the mission. We had to change out our Linhof film, and once your hands are in there, you can't come out till you're done. And there's you've got exposed film in there, and new film, and the roll you're trying to work it into, and finally success. I think Jay did most of our film changing during the mission. Briefly, a nice view from one of the aft cameras showing the payload and our aft windows.
The aft flight deck was really where we did all of our work on the daylight passes. We were doing a lot of photography in support of the radar observations. On the left there you see the Linhof camera mounted to a bracket on window number 7, and you could tilt that to line it up with the radar bore sight. And then Rich here is working with the 40mm lens out the window, and we had a lot of handheld shots of the targets of interest to the radar and the maps folks. This is a sweeping pass coming southeast across the California coastline, north of San Francisco, across the approaches to the Sierra Nevada, and very soon you're going to see some landmarks out here that you'll recognize from your geography lessons. The Sierra Nevada is the snow-capped range here. You come into view of Pyramid Lake right here, and then Lake Tahoe coming into view at the bottom of the screen. And as we walked down the Sierra Nevada, we saw our super site for hydrology at Mammoth Mountain, right next to Mono Lake here. This is where Mammoth Mountain is. And then if you follow the Owens Valley down the front of the Sierra Nevada, you'll come to Owens Dry Lake, right down at the bottom here, stepping across to Panamint Valley, and then Death Valley. And here you see Cotton Ball Basin and the Badwater, the lowest point in North America, at some 200 feet below sea level. This is a Jet Propulsion Lab graphic showing our radar imagery collected on the mission laid onto a topographic map of Death Valley. This is the northern end of the valley and Cotton Ball Basin, and as you fly through this virtual reality presentation north out of Death Valley, we sweep around the northern end of the Panamint Range, and this is the Stovepipe Wells target in Death Valley that we imaged many times on the mission, and we studied the interaction of the surface there with the wind and measured that with the radar roughness measurements. Now you can look back south down Death Valley to Cotton Ball Basin and Badwater, and these are the Panamint Ranges and the Black Mountains on the left. Here on the aft flight deck again, you see Jay using the 90mm Linhof camera. So we had 2 big lenses out the back window to document the radar sweep across the Earth. And I'm using the spot meter here to get the right exposure level for all of the cameras we're using on the aft flight deck. This is Siberia. It's so bright with this snow cover that you actually have to use sunglasses to get a good look at the surface down there. And we saw the Trans-Siberian Railway region many times in the first third of the mission as the top of our orbit took us over Siberia. We had a lot of ecological and geological targets in that region. Now we have a picture here of Jay and Rich conducting one of the many maneuvers on the flight to point the radar accurately. And as they entered the maneuver into the orbiter computers, then the orbiter did a slow walk during our passes to point the radar just so. This is the Sahara Desert region. We had a lot of investigations here to use the radar to penetrate below the dry sand in the Sahara to look at the bedrock below. And the drainages revealed by penetrating the sand sheet here show us how those drainages were formed and what the past climate of the Sahara was like.
Here's our payload commander, Linda Godwin, on the aft flight deck, getting ready for a pass down over the Ukraine and the Caspian Sea. Here you see the many farms in the Ukraine, beautiful area from out there, getting down to the area near the oil fields at the top of the Caspian Sea. And here's a beautiful geological feature there, going out to the Caspian, which is a very interesting feature studied by a lot of the scientists here at Johnson Space Center. The level of the Caspian Sea has changed greatly, and by studying features like the seacoast here, the folks here can tell how high the sea level has gone or how low it's gone. It actually has gone up about 2 meters in the last few months, about 6 feet. You can imagine what that would do to us here in Houston. You see the roads and so forth down there. Here's a beautiful picture of the radar in the payload bay showing everything out there. And here's the red shift, wearing blue shirts, on
You were wearing red shirts.
oh, that's right, on the flight deck. And you can see just how busy it was getting ready for one of these data passes. Overlaid here with, on the outside, is our TV cameras out in the payload bay, and on the inside, that little square is the radar. So you can see how much more is revealed by the radar. These white blobs that you see turning into black in the radar area are frozen lakes in Canada. We were talking to some of those people on frozen lakes. Down here on the Shuttle Amateur Radio Experiment, built by folks at Motorola and here at Johnson Space Center, and we loved talking to people on the ground with that. It really made us feel connected with them. We talked to students in 9 schools throughout the world. That's not all we did up there with the schools. We spent a lot of time on educational activities up there, both live downlinks that some of you may have seen, and making an educational film on geography, which we hope will be released for students in schools here real soon.
It's shift handover, and Sid's kicked the blue shift down to the middeck, and that's what you see us doing. Tom coming down, and I'm shortly followed by myself here. We're coming down to the middeck to do some of the orbiter activities associated with maintaining the spacecraft in good condition. You're going to see a shot of TJ here working out on the ergometer. Right behind Tom, over his left shoulder, is our rowing machine, which we also carried up there. Some people use the rower, some people use the ergometer. For longer flights, these things are almost critical to the operation. And the infamous galley is just above the rower there, where we had some problems. This was an experiment of moving a rigid body in space, getting ready for the sleep shift. It's sped up a little bit. It's 2 to 1, just so we can get it done in time. Then we had to slow the film down to show it to you. But the sleep stations were really handy. We had a good time with them. We used a 4-tier sleep station. The bottom tier was used for strictly stowage. And we did hot bunk. But the sleep stations really provided good, quiet, and light-tight area for us to get a restful 6 to 8 hours of sleep during each period. You're going to follow this with some more orbiter activities, mainly some meal operations and some cleaning. And you'll see the crew doing different operations and how we maintain good hygiene in space. This is Chili trying to show off his body.
A mistake.
What a mistake. But it's interesting to take a sponge bath up there, which is, of course, the way we had to do it. You just use the hygiene hose and put some liquid soap on the rag along with some water and wash off your body, especially needed after an exercise period. A quick view of some of the food operations. Behind the crew on the forward flight deck lockers are 3 food trays, which you can see are in use right now. They were useful for stowage. This is a water dump, a unique view of that. Chile has set up the water dump looking out the pilot's window number 1 and then giving you a close-up view of how it forms the ice particles immediately on expulsion into space. And following this, we're going to have some other experiments with space science here. This is seeing how a gyroscope works in space. These are our gyro-stabilized binoculars, and what I've done is I've just turned them on, and you can see how they try to maintain a position in space. These were particularly useful for looking at some of the Earth observation sites for close-up views. Now we're over to Chile.
Well, you'd think someone who'd flown before would know how to eat cashews in space, but of course, I got a little help there.
She does.
Got a lot of help, I should say. You got to enjoy yourself while you're up there in the little free time that you have between, and particularly when you got the whole shift or both shifts together. And Tom found a unique way to use the TIPS paper roll. When the roll was out, he turned it into a blowgun for shooting malted milk balls across the cockpit there. I think Jay was declared the champ here, the only one that could successfully grab one. Rich had done an experiment with fluids on his previous flight, and so he convinced us that we needed to do a little experiment on this flight. And this is always a good thing to show the school children how fluids behave floating free in gravity, and to demonstrate to them that this is not, in fact, a bubble, but a solid sphere of liquid. And Rick demonstrates that here as it wicks away onto the towel just before it hits the overhead window. This is the entry into, or the beginning of my favorite part of the flight, which is entry. And here we are on FCS checkout day, the day before our first attempt to come home. We didn't have many payloads that moved on this, so we had to throw the Elevon in here coming up during FCS checkout. The radar is pretty static back there in the aft. But entry was pretty fantastic. And, of course, there's always a little bit of regret with your final view of the last sunset on orbit before you come home. But As the sun sets on Endeavour here, we come back to a spectacular sequence here that Tom Jones shot. Carrying the camcorder in the back seat during entry here, you can see over Sid's shoulder in the front, the orange glow out the front, and now Tom zooms in on his mirror to look out the overhead window, and here's the wake of the orbiter during entry. And so you can see the hot plasma forming a plume of fire behind the orbiter. Out Sid's window, it's still hot and glowing. Out my window, you can see that we've gone into daylight. And in this tremendous right turn that we made for the majority of reentry around the Crater Lake and Mount Shasta and Mount Lassen in California and on down the San Joaquin Valley, it was just a tremendous reentry view as we came down the whole length of the state of California. Sid did a beautiful job rolling us onto the hack and flew right on the money all the way around here. You see him rolling out on final on the outer glide slope. Tom's still holding this 500-pound camera now. Looking out over my right shoulder, you can see the ramp there at Edwards Air Force Base. And Tom was a real trooper carrying that thing all the way down through landing here, having it at the ready to film a few sequences here. An absolutely beautiful day to land at Edwards Air Force Base, and Sid made an equally beautiful touchdown, nice and smooth. On the hard runway there, runway 22, we were constrained because of our weight and CG to land on a hard surface runway. So we had no choice other than Kennedy and Edwards 22 for coming home this day, and we were happy to come home after waving off the first opportunity. The drag chute worked as advertised, and rollout was great. Again, Tom looking over my right shoulder here as we jettison the drag chute, rolling out on the runway at Edwards Air Force Base to wheel stop. And I think after wheel stop, it's kind of a bittersweet moment for the whole crew. You're certainly happy and pleased to be back home. You hate to see the mission end, but one more time around the cockpit here, congratulations for Sid for a wonderful landing, and a happy flight deck crew, and no longer a rookie Tom Jones, getting ready for his next flight.
We've got a lot of ways of sharing with you, and one of them is the film for the things that moved on board, but mostly what moved on board was the Earth and us. So we'd like to use a few of the remaining minutes to show you a number of still pictures that we took with a lot of the cameras that we had on board. And the first few are of some of the crew. This, for those of you in the audience who created it, is our morning mail, and it would come out of the teleprinter over here, or out of the tags, I beg your pardon, and tips. Tips is what we're calling it. Thank you.
You just rented the whole history of
That's right. The fax machine. And would come out, and the crew would get together and look it over and post it to the books. This is another shot of waking up in the morning. Here's the red shift in their bunks. We thought the bunks were really swell pieces of gear, and we all got real good sleep in them. This is what it looks like getting ready to come home. This is Linda and her best friend on the crew. And it really was a good friend of all of ours, the suit. We got to know it real well after 3 wave-offs attempts at the Cape, and we're very glad to use it finally to come down to Edwards. And finally, this is a still shot of our aft flight deck, and you can see the myriad of cameras here in a little more organized fashion than we normally had them, including the big 4-inch by 5-inch Aero Linhof camera. And what we're going to do now is to show you some of the results of some of these cameras. And I should point out also on the aft flight deck, since there's some folks here that are from all of the centers that contributed, these are the integrated science timeline from the Jet Propulsion Laboratory down in the lower left, some maps from Jet Propulsion Laboratory right under the Linhof camera, and some maps that we created here at Johnson Space Center right by Tom's belly there. And we used all of those to find the features that we're going to next show you. Well, on the next slide is one introduction to the Earth. This is up around Alaska, right on the coast, and I think you can see how low we were. This, which is just about the view you had out the window, shows you some of the beautiful glaciers and the mountains on the coast of Alaska.
As Jace mentioned, we were pretty low on the trip, and probably the most exciting thing to do is to look through some of the cameras we had with the magnification on them. Most spectacularly, I'd say, was the 35 millimeter with a 300 millimeter lens and then a multiplier, which gave you a 600 millimeter effective zoom, and watch the world go by. This is San Francisco Bay. In the lower center, you can see the Golden Gate Bridge, and if you look closely on this photograph, you can actually see the towers of the Golden Gate Bridge as we flew by. So it was the detail that we were able to enjoy up there was very dramatic. Also, from a mission point of view here, we see just off the coast or past the mouth of the Golden Gate, you can see the extension of the San Andreas Fault here that runs up the coast of California and then off into the ocean as you go a little further north here of San Francisco. My hometown, so I had to show this picture. This is Los Angeles, and we had, believe it or not, 3 clear days over L.A. And actually some really pretty photography. Of course, some interest. The San Andreas Fault continues on down through this area, and just off the photograph to the north would be the epicenter of the last major earthquake they had in Southern California out by Northridge. But of course, the most important picture here, and I point this out for our training lead, Don Thomas, is Dodger Stadium, which is located right here. On into some of our science objectives. This is the Mammoth Mountain area, Mono Lake, California, in the top right-hand corner of the picture you may have heard of. And then just down below that area is Crowley Lake, and those are the pointers we used looking out the window to take photography of this mountain area right here in the right center of the frame, which is Mammoth Mountain, California. It's a big ski resort, but we weren't taking pictures for future ski trips. The interest in this area, of course, for California is a hydrology interest. You know, they've come out of a period of drought, and now they're in a pretty reasonable shape for water consumption out there, but there's always the threat of a drought in this area because of the large population in Southern California taking the water out of the Sierra Nevada and using it for drinking and other purposes. One thing we've never been able to do is predict the amount of water runoff from the snowpack. We're still using the same techniques we used 50 years ago, sending skiers up into the mountains during the winter and pounding pipes into the snow to estimate the depth of the snowpack. But that doesn't really give you the density of the moisture in the snowpack, because if you've ever skied or been in the mountains, you know, you can have some dry snow days, some wet snow days. And so just measuring the depth doesn't really answer the question. And there's a lot of hope that the imagery taken by the radars on this particular flight and on future flights will help us to better predict the actual moisture content of the snow in the Sierra Nevada and at other sites around the world, and so that we can better predict runoff and forecast the possibility or probability of droughts for the coming season, and then we can better manage and ration our water system. Further on down the Sierras and just a little bit to the east from Mammoth Mountain was another major site we had, and that is Death Valley. And as we pointed out earlier on the film, the area in and around Death Valley was interesting to us from a scientific point of view for a couple reasons. Scientists are studying the movement of sand in this area, aeolian effects they call it, and the movement of topsoil, if you will, due to the wind effects. And so one of their test sites up near the sand dunes in the northern portion of the valley was being observed. In addition to that, areas known as alluvial fans, which are large runoffs, mostly caused by water eroding the mountainsides. And there are huge fans out in the Death Valley region that we think were caused back in the last period of glaciation in this area. And we don't have any real good method of dating these fans or mapping them around the world. And the radar provides this opportunity to do that, and turns out to be a good platform for measuring them. And once we've calibrated the radar based on these sites in Death Valley, we'll be able to measure them all around the world. I'd like to go to a radar image of this same picture. Here we are looking at Death Valley again, and a similar image that we saw in the motion picture that Tom narrated, where we flew down into the valley using the radar imagery. So the big advantages to the radar is it gives us an opportunity to look at these things in a way we can't look at them and get information that we cannot get from visual photography or from infrared. And it gives us a year-round capability to do this, whether it's sunny out or cloudy.
This next frame switches us all the way across North America to the East Coast. And if you look in Western Virginia, you'll recognize, I've got this one, okay. You'll recognize the two forks of the Shenandoah River here as they run up towards the Potomac. This is the South Fork and the North Fork of the Shenandoah River in the Shenandoah Valley right here. And the two forks join and then run up with the Shenandoah River to the Potomac up here in western Maryland at Harper's Ferry. This is a great picture because it shows how sun glint can light up hydrologic features like these river valleys, and we looked for this all around the world as part of our documentation of the areas being imaged by the radar. But it also just gives you a great view of some regional history. This is the Blue Ridge running right along here from Front Royal, Virginia. You can actually, in this photograph, trace the Skyline Drive up here along the mountain ridge as it goes south towards North Carolina. Also, from Front Royal all the way south past Sutton Mountain here, you can see the whole area that Stonewall Jackson made famous back in 1862 when he confounded the Yankee armies in this entire Shenandoah area. And then later at Cedar Creek in 1864, Phil Sheridan cleaned the rebels out of the Shenandoah at a famous battle here. So this is a great view for me personally. I've tromped over a lot of this area, and it was great to see it from orbit. And this was just to the south of a big radar swath that we repeated on many days that cut across the Appalachians in Pennsylvania. This is a superb view of the New York City area at night. And we were all struck by the beauty of the cities in North America and around the world, but particularly in our own country, by the star-spangled effect of the cities on the black velvet background of the earth. And you can see a lot of detail in this picture. This is Manhattan Island here with the dark oblong of Central Park. In the original negative, you can see the two lights from Ellis and Liberty Islands, and the Statue of Liberty is about right there. JFK Airport is here, and of course this is Brooklyn and Queens and Long Island stretching out into the ocean to the east. Over here is Staten Island and the New Jersey coast up along the Hudson River proceeding on up towards West Point, which is Rich's alma mater. And these sites were just stunningly beautiful each night as we came up across the continent. Here we skip across the Atlantic. One of the oceanographic sites that we imaged almost every day was the Straits of Gibraltar. And the radar imagery here was aimed at looking at internal waves and the circulation of ocean currents in and out of the Mediterranean as we flew over each day. Now you can't see any of the currents here in this picture, but you can see a lot of the regional geology. This is Spain. The Sierra Nevada here is snow-capped over along the Mediterranean coast. You can see from Gibraltar here around the headlands out into the Atlantic, this is Cadiz, and Sevilla, one of the larger cities in southern Spain, is right here. Across the Straits of Gibraltar is Tangier, and then you see the first traces of the Atlas Mountains stretching off into North Africa in this picture. And this is a wide-angle shot that gives you a good sweep over the Mediterranean. We were actually much closer to the ground visually by using the naked eye or with our telephoto lenses. This is a shot of Kuwait City in the head of the Persian Gulf. And this is the Persian Gulf stretching up here to the Shatt el-Arab and the border with Iraq. And this is the city area itself. And the amount of detail in this photograph is really quite amazing. You can see the large international airport here, even down to the white blocks at each end of the runway. We could also see a lot of the street grid very clearly, the docks here in the harbor. And down to the left edge of the photograph are some oil fields, and you can see a faint trace of the soot left on the sand from the fires of about 3 years ago. And Linda notes that when she flew with Jay on STS-59 3 years ago, this entire area was black, soot-covered, and there was a huge smoke pall, of course, over this entire area. So the change is quite dramatic.
In the previous view, if you just move north of Kuwait City up into just inland of the north end of the Persian Gulf, this is another area in Iraq. Most of the time when we fly around the world, we don't have a whole lot of insight into the politics that are going on the ground. But in this area of Iraq, the marshy area, in the, I guess as you're viewing the photo, in the upper left corner, or most of the upper part, has been drained, and now Saddam Hussein has set fires in that area basically to try to drive out his foes that live there. So these were one type of the human-made fires that we did identify on orbit for science reasons in terms of our air pollution sensor, but also it's just kind of an interesting picture here because it gives you some insight into what's going on politically on the ground in this part of the world. And this is Lake Balkhash in Kazakhstan. A couple of things to point out here. First of all, you'll notice that it's ice-covered. And in a lot of the northern hemisphere that we flew over during our mission, we saw a lot of ice, and the state of the water on the ground is of interest to the radar people because their instrument receives a different signal from the ground depending on how the water is, whether it's flooded, arid, or frozen, or some in-between state. And here you can see the ice is beginning to crack. On our mission in April, we really saw this kind of, both in Canada and in Russia and Siberia and Kazakhstan, and basically the northern hemisphere, we saw the change of state of the world there going from winter to spring. Another thing that we tracked in north is basically down or to the lower left corner in this picture, and you can see the snow line here. And this is typical of how we could see the snow line on the ground, and at various parts of the world as we went around, we did see it receding toward the north during the mission. That's typical of the kind of observations we tried to keep to help out the investigators so they can interpret their radar data. And this is the Aral Sea. At one time, it was the fourth largest body of fresh water in the world, and it's slowly been shrinking. This is an area that's been photographed several times from space. It's one way we've been able to keep an eye on it. And it's basically induced by humans siphoning off water for irrigation for their cotton fields. So this part of the world definitely is changing state. And we had a radar site about 100 miles north of here, so we had our ground tracks take us near this area several times during the mission. This is the Burma and Bangladesh. If you can imagine, at the top of this slide is south. And over here, another example of how we could see fires from space. It took a little practice, by the way, to make sure that we were identifying fires and not smoke, not clouds. But it became easier during the mission, and when you look real closely, you can tell the difference because there were always point sources, basically, for the fires. Although in this picture there are so many of them, they almost start to look like clouds if you can't see the source of the fire. And over here is the mouth of the Ganges River, and just shows you the kind of things we can also see from orbit, the sediment washing into the water. And if you can imagine, just almost east of here and out of the upper right corner of the slide is Calcutta. And this is
this is a view of Lake Baikal, again in central Russia. It's just above the Mongolian border. And this is, as you can see, the entire lake is covered in ice. I saw this same view last December '92 on STS-53, and one of the interesting things that Tom's going to be able to see is by flying over it in August, he's going to see that the lake should be free by that time and should have a different color. Another interesting fact is that the lake looks almost white. The ice is white. However, when you look at Lake Balkhash, it was kind of a blue ice. So it's an interesting feature, which both of them were imaged by the radar. It might be interesting to see the difference between them. You can see some features here. This is the Selenga River Delta shown up here, and the city of Irkutsk is just right around in this position here. Continuing our walk across Asia, we're looking at the Kamchatka Peninsula here. A radar site looking at several things. One, ice flows in the Sea of Okhotsk, which is here. We're looking to the south on this view here. And volcanoes, the Besimiani and Kurshikoya. And Chili's looking at me very funny about my Russian-speaking capabilities. But you can see clearly some of the sea ice that's formed along the coast here along the Pacific Ocean. This is in the Kuril Island chain, just off the southern edge of Kamchatka. This is Onikotin Island, and you see the remnants of two large volcanoes with their calderas. This was a very pretty sight to us. This is Osaka Airport, the floating airport they built in the Osaka Bay, and that's one long runway. Possibly using it for a contingency landing site. Maybe not.
We're in the Philippines now, a little bit south of Kamchatka, and we're looking at Mount Pinatubo, which is one of the volcanoes, or the volcano in the Philippines that made so much noise and news some years ago when it erupted. And you'll recall that as a result of that, Clark Air Force Base down here eventually wound up being closed as a result of that and the political climate, but the eruption put so much ash on it that it was economically not smart to go back and recover it. One of the concerns now is because of all the flows and everything coming down from Mount Pinatubo, they're becoming concerned about eventual mudslides and what that may have on the area around the volcano as well as the villagers and the villages and everything that are located around the volcano. We imaged it with our handheld photography, and we also imaged it with the SRL with the radar, and this is a picture of what it looks like from the radar. You can see that you get a lot, you get different detail, you see different things when you're looking with the radar, so they complement each other, and it's nice to have both of the photographs to compare the two and learn more about what you're looking at and what you're studying without actually having to have people all over the site that you're imaging at that particular time. This is a shot of another site that we imaged a lot. It's a real close-up of the Galapagos Islands, and you can see several volcanoes on them, and they're basically giant shield volcanoes down here, and the Galapagos are very interesting islands because there hadn't been a lot of contact between them and other parts of the world, so there's some very interesting species that live out there. As we were flying over the islands on our flight, you may recall one time we called down and indicated that we saw a rather dark cloud over part of one of the islands, and we weren't sure exactly what it was, but it was darker than the typical clouds you would see from space. And about 24 hours later, the ground payload community got back to us and told us that there was indeed a fire on the islands. You may have read about it a little bit since then. The fire's been burning and it's been threatening some of the interesting species down there, including some large tortoises, I guess. So we took some SRL photography of this area also with the radar. This is the one constellation that I can recognize. I've always decided that if nobody else could recognize additional constellations, if we ever lost our inertial units on orbit, we'd have to go round and round the world till I found Orion. And this is Orion here. You can see the most visible part of it here. And it's, as you see it, it's just above the atmosphere, and you can see some of the aurora here. And so overall, we think this is a pretty spectacular photograph. Obviously, the stars are pretty big because we had to expose it for some period of time in order to see it because it's shot at night. I was very excited to see the aurora on this flight because my last flight was into a 39-degree inclination, and we didn't get to see the aurora from there. I'll tell you a couple things about it. First of all, it's seeing it, the photographs really do justice to it in terms of its color and basic visual characteristics. So being able to look at a photograph of it is very close to seeing it up there in orbit. The big difference is that it actually dances around a lot. So if you can see, there is some motion picture or camcorder photography of it, and that does a pretty good job of capturing the movement of it. It's amazing that it jumps around the way it does. And the last thing that you can't see from the ground, unfortunately, is the fact that you're actually flying through it. I mean, here we're kind of looking out at it, but in this case we're either, I don't know whether we're nose forward or tail forward at this time, but we've either just flown through this or we're getting ready to fly through it. And it's actually amazing seeing this stuff up there going up, you know, well above what you would normally consider the atmosphere, and then you're actually flying through it. And this gives you just a little bit better shot of what it looks like out there. This is the payload bay of the orbiter and the tail, and you can see we're flying through or have just flown through it, and you can also see an RCS thruster jet firing here. So it's a pretty amazing photograph. We shot quite a few photographs in order to get a few of these that actually turned out because they're so difficult to expose. But we thought it was worthwhile, and Jay got a lot of film on board for us to be able to expose a lot of photographs and wind up with a few to bring down to, I think, really capture for folks here on the ground what it looks like to see this up in space. It's probably the most beautiful part of this particular mission, I thought, was looking out and seeing the aurora.